Hi, it's Barbara. These are computer vision worksheets. In this exercise, we are going to get to know an important image processing technique, namely histogram equalization. This technique is used to improve contrast between elements of an image. So let's see how it's done. So the first thing we need to do is to count the number of occurrences of each pixel value in the image. Here we have the teeny tiny 5 by 5 image. And we have to calculate how many times each value occurs. We have values from 0 to 7 because we are going to use 3 bits to encode this image. So we have no zeros, we have a single 1, and now let's plot these values. At the end, when we compare these two plots, we are going to see the effect of this method. Now let's fill in another table. First row tells us to calculate the probability density function, and we can do this by calculating the number of occurrences of each pixel value and divided it by the sum of all pixels. Sum of all pixels is going to be 25. And now let's divide each of these values by 25. And apparently we have one row missing. Okay, so now for the next row we have to calculate the CDF, and we can do this by calculating the cumulative sum. So for the first value we have 0, then we add 0.04 to 0. And for another row we have to normalize this value, that is, divide each of these values by the maximum intensity value, which is 7. And now we have to round the result to the nearest unit. And now we have to fill in the resulting image after histogram equalization. So basically the last row tells us how to map the values from the original image to the new values. So now 0 is mapped to 0, 1 is mapped to 0 as well, 2 is mapped to 3, and so on. And now let's plot the result. And we can see right now that, that when we compare these two plots, we can see that the result after histogram equalization has the bars more spread out than the original image. And therefore, we should be able to differentiate the specific features better because the values are more spread out from one another, so the contrast should be improved. And for the last part, there are many modifications of the histogram equalization method, and the adaptive histogram equalization works in a way that instead of calculating just one histogram, it calculates several histograms, and each of these histograms corresponds to a distinct section of the image, and then we use this histogram to redistribute the lightness of values in the image. And the limited value applies this procedure to the specific neighborhoods. So these are the two modifications of the histogram equalization method.